Hello everyone. Now we've learned how to take derivatives of trig functions. We'll do a couple applications here. So for first example, the voltage delivered by a combination power supply at time t is given by the equation v of t is 5 sine pi t plus 12. Determine the times at which the maximum voltage occurs. Okay, because we want a maximum, that means I'm looking for the critical points of my derivative. So v prime of t is equal to, okay, so I have a constant times a function, so I can leave the 5 alone for a second. Derivative sine of something is cosine of that same something, okay, times the derivative of the inside. So derivative of pi times t is just pi. Okay, so bringing that pi over to the front, I have 5 pi times cosine of pi t. Okay. And of course, the derivative of this 12 by itself was 0, so that's gone. Okay, I want to know my critical points, so I set that equal to 0. And now I start solving for t. So for instance, we'll divide by 5 pi. So we get 0 equals cosine of cos pi t. Okay, I got to solve, so I do cosine inverse of 0, and it's equal to pi t. Okay, so for cosine inverse of 0, your calculator will probably give you pi over 2 right away. The other option for this, okay, like that's 90 degrees. The other option is 270, which is 3 pi over 2. Okay, and that's like 360 minus is also a solution when you do cos inverse. Okay, as for times, so I'm going to do this as a general solution. So plus 2 pi k plus 2 pi k is equal to pi t, right? Because a full rotation of the angle is also a solution to this. Okay, so finally I divide everything by pi, and I get 1/2 plus 2k and 3 over 2 plus 2k are my possible values for t. So realistically, right, a ½ second and 1.5 seconds plus the period, which is 2 seconds. Okay, so now one of these is probably the max and one of them is the min, right? We know it's a trig function, so we're going to get one of each. Okay, so the question is, which is which? So we could do that with the second derivative test. So let's copy this out. Pardon me, this thing has not liked me today. Okay, there's my derivative. So let's do our second derivative. And actually, I should use the tidied up version. So that was 5 pi. Okay, so for v double prime, okay, my constant stays where it is, 5 pi. Okay, cosine, derivative of cosine is a negative sine of pi times t times the derivative of the inside again, which would be another pi. So I have a negative 5 pi squared sine of pi t is my second derivative. Okay, so let's start with 1/2. Okay, if I do v double prime of a half, okay, I have negative 5 sine pi squared. Okay, so I would have pi over 2. Okay, sine of pi over 2 is 1. Okay, so that means I have negative 5 pi squared. Okay, my second derivative is negative, therefore it's a local max. Okay. Similarly, if I do v double prime of 3 pi over 2, okay, that would be negative 5 pi squared. Okay, sine of 3 pi over 2, when I sub it in, would be -1. Okay, so I get positive 5 pi squared. That means my function is concave up in this region, so therefore these ones are the local mins. Okay. So therefore, the maximum voltage occurs at, right, a half second, 2.5 seconds, etc. Okay, right? So the first instance is at a half second, and then every 2 seconds after that. Okay. I know maybe you might have thought of this while we were going through here. I know every year when I teach this section, a student points out that, well, instead of doing a second derivative test, couldn't you just go back to the original function and plug in a half there and 3 halves there and see which one is the max and which one is the min? Okay, and the answer is yes, right? If you plug that in, you'll get 17 when you plug in a half, and you'll get 7 when you plug in 3 halves. So yes, that does work with a trig function, especially this type, right? Because it's just up, down, up, down. So okay, does it work? Yep. Can you do that? Yes. But just keep in mind that really only works because this happens to be sine or cosine. Okay, but that is another way you can check with a trig function. Okay, so one other example. This is coming from the textbook. It's on page 238, but I'll talk it through a little bit. It says to determine the maximum speed of a pendulum with a length of 1 meter and an amplitude of 5 centimeters. Okay, and the first time this speed occurs. So because it says speed and not velocity, technically it doesn't matter if it's positive or negative. I just want to know what the biggest number is going to be. Okay, so part of this is, and it's listed in your textbook in the example as well, but to find the period of a pendulum, you have to use this formula. Okay, it's 2 pi times the square root of the length of the pendulum divided by the force of gravity. Okay, so the length here is 1 meter, they said, so it's going to go in for L. So let's start working this out. So the period is 2 pi times the square root of 1 over, okay, 9.8. Okay, when you run that through on a calculator, it actually comes out to be remarkably close to 2. It's like 2.005 or something like that. So to make our lives easy, we'll call the period 2. Okay. It says our amplitude is 5. Okay. So if we're going to release this from rest, okay, that means we'd be starting at the peak. So my function for the position of the pendulum would be something like, let's say, I'll use it for position, maybe S, I'll use S of t for this. Okay, is equal to 5. Okay, I'm going to use cosine because it's going to start at a peak and then swing towards the middle. Okay, our period is 2, so that means 2 pi over b equals 2. Work that around. B is equal to pi. Okay, so cos pi t. So that ends up actually being very similar to the equation that we just looked at. Okay. Okay. So now it wants to know what's the maximum speed of this. Okay. Well, this is our position. Okay. Our function for speed or velocity, okay, we'll use velocity for the moment, right, is equal to the first derivative of this function. Okay. So when I do my derivative, the 5 I can leave alone for a second. Derivative of cosine is negative sine, so I'll pop out a negative there. Okay, pi t, and derivative of the inside is pi. Okay, so my velocity function is negative 5 pi sine of pi t. Okay. I want to know the maximum velocity or speed. Okay. That means I have to find the critical points of its derivative. So really, I have to go ahead and take the next derivative, which is acceleration. So s double prime of t is going to end up equaling -5 pi squared cosine of pi t, right? I left my constant alone. Derivative sign is cosine, and I got another factor of pi when I did the derivative of the inside again. Okay, and now it's the same thing we did in the previous one, right? I would set this equal to 0. Okay, -5 pi squared cos of pi t. Okay, and as I mentioned, it turned out this formula was very similar to the last example. So when I run this through, I am actually going to get the same thing I had before, right? I can either have a half or 3/2 as my value of t. Okay, so plugging it back in to my speed function. Okay, so I had v of t. So v of 1/2 is equal to -5 pi sine of pi times that, so that's pi over 2. Okay, so my largest velocity in terms of negative is -5 pi. Okay, similarly, v of 3/2 is going to equal +5 pi. Okay, so again, getting the decimal equivalent to that, it's about 15.7. Okay. So the fastest speed, the amplitude was in centimeters, so this speed would be in centimeters as well, centimeters per second. Okay. And that's pretty much it. Okay. So again, it's in most cases for these questions, right, it's going to talk about, maximum something or find the rate of change of something, take your derivative and go from there. Okay. So for practice, okay, there are the practice questions I would like you to look at starting on page 241. Okay, one thing I just want to note, if you're having a look at some of these, is that sometimes they describe the frequency in hertz. Okay. Okay. And they give you that information, okay, instead of the period. Okay, the relationship between period and frequency is that the period of a function is 1 over the frequency. Okay, all right, because period describes how long it takes for one cycle to complete. Frequency is the number of cycles that occur in 1 second. Okay, so they are just the reciprocal of each other. So if it gives you something in, hertz, it means so many cycles per second, and then you do 1 over that to get the period of the function. Okay. Thanks for watching. If you have any questions, feel free to send them along.